Hello everyone, Quentin Anderson here from Eagle 3D Streaming. We have a wonderful tutorial for you today on how to set up and deploy an Unreal Engine project using pixel streaming, especially for BIM-based workflows. Through this tutorial, you're going to learn how to cover the basics and some of the challenges when deploying your application to the cloud. Specifically, we'll show you how to pick the correct cloud for pixel streaming and how to benchmark your Unreal Engine application so that it runs appropriately in the cloud. We're also going to show you how to effectively manage large files in the cloud, and we'll also show you how to address latency while streaming. Let's dive right into the tutorial. The first thing to cover is, well, what exactly is pixel streaming? As you can see from my screen, pixel streaming is when I stream an Unreal Engine application into a browser. The reason people like to pixel stream is because this allows us to run the Unreal Engine application in the cloud on a powerful PC and then stream the output to the user, allowing them to access high-fidelity Unreal Engine content from their browser. The benefit of using pixel streaming is that the user no longer needs a gaming-grade PC in order to access your high-fidelity content. This is because the application runs in the cloud and the stream is sent to the user's device. And as long as they have a powerful internet connection, then it's very easy for them to access your high fidelity Unreal Engine content from any device as long as they're connected to the internet. And this is one of the primary reasons we use pixel streaming, is because it removes the hardware dependencies of accessing Unreal Engine projects. And the next step, I'm going to briefly go over how to set up a project for pixel streaming and get you streaming into a browser. Now that I'm an Unreal Engine editor, let's go ahead and set up our project for pixel streaming and get streaming into a browser. The first thing I need to do is to click on Edit, then I go to Plugins. Once the Plugins menu comes up, I'll type in Pixel Streaming, and I will select this first option, which is Pixel Streaming. There are two other options. Pixel Streaming 2 is still fairly experimental, and then this is for the pixel streaming player, which allows you to stream into a game. The option that we want, however, is the first one, and I'll just go ahead and select it. You may receive a notification down here that you need to restart editor, and that's totally fine. If you receive that notification, just go ahead and do so. But once I have pixel streaming enabled, I'll then close the plugin menu and we can now build our game. The way that we do that is we just go to Platforms and select Windows and click Package Project. I'll go ahead and select my folder and the packaging process will begin. Once the project is finished packaging, then we can move on to the next step, which is pixel streaming into a browser. Now that we have our Unreal Engine project built with the pixel streaming plugin enabled, we can go through the process of now pixel streaming into a browser locally. In order to do that, the first thing that we should do is go into our built files folder, which I have right here. And now let's get the pixel streaming server set up. In order to do that, I double click on my UE project file name, then I double click on samples, then I double click on pixel streaming, web servers, and then double click on Get PS Servers, which will get all of the pixel streaming servers. Then the next thing that I need to do is let's go back to the root folder of my built files and let's create a shortcut for the Unreal Engine executable. I do this by selecting it, right clicking, and then clicking on Create Shortcut. Then once I have my shortcut created, I select this, right click again, and I select Properties. After I've selected Properties, then let's go into the target and add this command line, which I will also of course provide in the description. So I go to the very end of the target and then, so I go to the end and then let's paste in this command right here, which this tells the application where to find the signaling server so that the application can stream video and audio through the pixel streaming system. After I have entered in this command, I'll click Apply and then OK. And then next, let's set up and run the signaling server. And in order to do that, I'll first go back to my project name, then double click on samples, pixel streaming, web servers, signaling web server, platform scripts, command, and then let's first double click on setup. And typically you'll just see a command line window flash briefly. And then once that's done, then let's double click on start with stun. Once this initiates, then you'll see that dependencies are going to get installed. And I'll pause the video while this is being done so that we can resume the process. Once the installation is complete and the signaling server is running, you will see this command or this information listening for streamer connections on port 8888. That's how we know the pixel streaming server is running. And do keep in mind that you do need to have the signaling server running in order to pixel stream. So if you're doing this again from scratch, just double click on start with stun and you'll see that the signaling server is now running. And of course, just double check that the signaling server is running so that you can actually pixel stream. Okay, so once that I have confirmation that my signaling server is running, and I know that because of this information right here, let's now start up the Unreal Engine application. The way that I do this is I first go back to my root folder, which is right here, and then I simply just double click on the shortcut that I created, which will start the Unreal Engine application. I'm going to type some information right here, and don't let this be confusing. This is actually part of the Unreal Engine application and has nothing to do with the game. And I just entered in some basic info so that I could actually get to the application itself. At this point, we are now successfully pixel streaming. However, an important note is that if you were to try to pixel stream on a device that's not connected to the same network using that IP address, it wouldn't work. And the reason is because there's some additional steps we have to take to pixel stream over the internet. So what I'm going to do right now is I'm going to go over an overview of what exactly a cloud is, how to select a cloud, how to select a GPU for pixel streaming so that you have a proper foundation. And then we also have some tutorials. Once you've selected your cloud, we have some tutorials on how you can configure that cloud to pixel stream over the internet. So let's first start with selecting our cloud for pixel streaming. And in order to determine that, it may be helpful to explain why we need a cloud in the first place. All a cloud is the server that's running or hosting your Unreal Engine application. And there's lots of clouds out there. There's Google Cloud, there's AWS, there's Azure, there's CoreWeave. All of these clouds serve the same purpose, which is they will host your Unreal Engine application. In the diagram that I'm sharing, you can imagine that this is the cloud that you've chosen with your Unreal Engine application running in it. And then that application is then streamed through the internet to a user's device. Now you could pick any cloud that you want and they will all function the same, which is they serve to host your Unreal Engine application so that we can stream it over the internet. And that's exactly why we need a cloud. Now let's go over a couple of examples of which clouds you can use. What I'm sharing on my screen now are two clouds that we commonly use for pixel streaming. Of course, you can use any cloud, GCP, Azure, Oracle. We're going to go over two clouds that we commonly use for pixel streaming because we find them to be a good mix of performance and cost. The first one is CoreWeave. Now, CoreWeave is primarily United States based, so you'll have to keep that in mind for latency, but they do have a few GPUs available that are pretty good for pixel streaming. That is the A6000, the A5000, and the A4000. Now, in terms of comparison for commercial GPUs, like the RTX 3070, 4080, we find the A5000 to be roughly similar to the 3070, and you want to keep that in mind when you're doing your benchmarks. On the pricing side, the A4000 is 61 cents a minute, the A5000 is 77 cents a minute, and the A6000 is $1.28. And these are per hour for the GPU component. Of course, there will be some additional cost for CPU, storage, IP addresses, but this is just to give you an idea of what CoreWeave's rate is for GPUs. We find it to be one of the most economical in the entire market. Another option that we sometimes use is AWS. AWS also has a few options available for pixel streaming. The first one is the G5 instances. The G5 instance provides an A10 GPU, and the one that we commonly use is either the 2x large or the X large. The difference is the vCPU cores available and the amount of RAM available. A good thing about the A10 is the card itself has 24 gigabytes of video RAM, but in terms of performance, it still runs from a frame rate perspective similar to the 3070. So expect to get about 3070 performance from a frame rate perspective, but you do have some additional video memory. The other instances that are available are the G6 series, which are a little bit newer, and the G6 series provides the L4 GPU. And again, you could go with either the G6 X large or the G6 2X large. Again, the difference being just the amount of vCPU cores and the amount of RAM. The other option that you could potentially go with is the G6E. And again, you could do the G6E X large or 2X large depending on how resource intensive your Unreal Engine application is. Let's also take a quick peek at pricing so that we kind of know what to expect. So the G6 instance is $1.34. Again, if we're kind of comparing that to CoreWeave, it is a bit more. So, of course, keep that in mind. And if we look at the G6E 2X large, it's $2.06 a minute. So these GPUs are more powerful, but they will also cost more per hour in order for you to use them. Lastly, if we take a look at the G5 instance, the G5 2X large is $1.21 an hour, and the X large is roughly $1 an hour. So far, I've gone over two clouds that we like to use for pixel streaming. CoreWeave is a little bit more is the most economical, and then AWS is a good mix of reliability, GPU options, and pricing. If you would like to use either of these two clouds for your pixel streaming, we have step-by-step guides on how to fully set up your pixel streaming server on both AWS and CoreWeave. So this will get you all the way through the process, and you'll be able to pixel stream on the internet if you would like to use either AWS or CoreWeave. Okay, in the next section, I just want to dive in a little bit on benchmarking so that we know what to expect when running our Unreal Engine application in the cloud. As you can probably imagine, the cloud GPUs are going to be different performance-wise than the GPUs you use to develop the Unreal Engine application. So it's important for us to have an understanding of the types of performance we're getting from the cloud GPU, just so that we can be better prepared to address issues when we see problems in frame rate while pixel streaming. So I'm going to go over a little example right here to illustrate an important point, which is there's actually two frame rates when we're pixel streaming, and some tips and tricks on how to approach issues when we see problems in the frame rate. So the first thing that I want to do is we have this Unreal Engine application running locally, and let's just check out the frame rate. I hit the tilde key and then I type in stat FPS and I press enter, and I can see my frame rate is running at about, 80, 90 frames a second. Now let's go and check out the frame rate on the pixel stream. If we then go and check this out, you'll notice something different, that the frame rate is right around roughly 60 frames a second. And the reason that is because there's actually two frame rates when it comes to pixel streaming. The first frame rate is the frame rate associated with the game engine that's running, and the second frame rate is the actual frame rate associated with the stream. To illustrate this even better, let's take the max frame rate and let's drop it down to 5 frames a second. So I'll hit 5, and then I'll go ahead and close that, and then I'll restart the instance, and now you can see these trees blowing at around 5 frames a second. But if we go to the actual Unreal Engine application, it's still running at 90 frames a second, and things are still butter smooth. So why is the pixel stream all of a sudden running at 5 frames a second? And the reason is because there's two frame rates. So there's a frame rate the game runs at, and there's also a frame rate that the application streams at. And it's important for me to show these differences to you because if you run into an issue with frame rate, just knowing that there's two different ones helps you diagnose the issue better. So the first thing that I always recommend you doing is first go and check and benchmark your Unreal Engine application on the server that you're going to be using for streaming. And this is, obviously very simple. You just run the Unreal Engine application like I'm doing right here. And then the other thing that I like to do is just open up your task manager and check resource utilization. You'll be able to see if there's any issues or any problems with the GPU, CPU, or memory. And you can also check your frame rate as well so that you have an idea of resource utilization and you have an idea of frame rate. And that right there, just taking that small step, will help really prevent and make it a lot easier to address issues when you run into frame rate while streaming. So because I know that my frame rate is really around 90 frames a second and I'm seeing a low frame rate, this is probably related to internet. And this is a good example of just whenever we see issues associated with low frame rate, because I know and I've benchmarked my application, I know it's running at 90 frames, I've tested it, that will allow me to better know, well, if I'm seeing a low frame rate, then it's probably related to internet or network conditions. Now, on the other hand, if you're seeing a very low frame rate in your Unreal Engine application, then this will be the source of the issue, because if your Unreal Engine application is running at 10 frames a second, then the stream will not be able to run higher than 10 frames a second. So you can see you'll be able to immediately address where the issue is, whether it's running from your game or if it's caused by the network. Before we move on to the next section, I just want to cover one more important piece, which is if you are going to use the resource monitor by Windows, it's pretty good, but we do sometimes see some issues with it not being 100% correct. So we also recommend using FPS Monitor. They do have a free trial, but it is paid if you end up getting it. And this is really something that's helpful if you really want an accurate representation of resource utilization, you can always try this. Okay, in the next section, we're going to switch gears a little bit and talk about how to manage large files in the cloud.
Tired of the will it or won't it run game? You've built your Unreal Engine BIM project, but the cloud is an unknown. You need to validate your application without the time and expense of a full-scale deployment. We provide a definitive answer, not a guess. Get clear answers with the Eagle 3D Streaming Cloud Readiness Benchmark. Just upload your app, join our Discord, and introduce yourself in the hashtag benchmark channel. We'll deliver a comprehensive performance report showing you exactly how your project will perform in the cloud.
Hi, so in this video I will show you how to create patch system in Unreal Engine using .pack files. This lets you generate small patch updates for your project so end user can download only the changes instead of re-downloading the entire build. So let's get started. Okay, first of all we need to go to the project settings. Under the packaging you need to disable this one. Yes, just disable this one. Okay, so we are good now. Oh, we need to enable this one, retain stage directory. We need to enable this one. So make sure you do these two things. Okay, after that, go here, go to platforms, go to project settings. Oh, we are working with the pixel streaming, so we need to enable the pixel streaming plugin also. So search for pixel streaming. So this is pixel streaming. The angel will recommend you to restart. So click on restart now. Okay, so the project is restarted now, and you can see a pixel streaming tab over here. So that means the pixel streaming plugin is enabled. Okay, so I will go to network. Okay, so first of all we need to go to platforms under project launcher. Okay, we need to add some profiles. So click on here, create a custom profile. I will name this one like base profile. So this will be the base profile of our game. Now project will be any project. The build configuration will be development. Okay. The cook function will be by the book. Now we need to select the cooked platform. This will be Windows. The cooked culture, that will be by default en, that means English. Okay. And the cooked maps, this will be this one, lv underscore exterior. So select the one which you want to cook. So I will select this one. Okay. uh, Under the DLC and the patches, okay, we need to create a release version of the game for distribution. Yeah, tick this one. This is a game base version, so this will be 1.0. After that, we need to enable disable, yeah. We need to enable the iterative cooking. Okay. We need to compress the content, and we need to store all content in a single file. Okay, okay, so that's good, that's good. And the packaging will be package and yeah, package and store locally. And by default, yeah, this is good. Deploy, do not deploy, and we are good. We are good with the base profile. Now hit back. Now run this profile. Okay, so first of all, if we play the game, okay, so this will be the game look. Let's create our base game. Go to project launcher. This is our base profile, so click here. So launch this profile. Okay, so let's do some changes. Okay, so let's do some changes on the map, and let's create a patch file out of it. So let me go to under levels. I will search for lighting. Okay, so yeah, this is lighting. I will hide the summer one. I'll go here, change streaming mode to blueprint. Okay. Yeah, now save this one, save the level. Now, oh, okay, I'll hide this one. Okay, the early morning looks good. I'll select this one. Now change streaming mode. Now select to always loaded. Okay, let's save everything. Don't forget to save. Okay, so after that, go to platforms, project launcher. Now add a profile, create custom profile, name this one patch one. Okay, project will be any project. Under build configuration, yeah, this is good. Book will be by the book. By the book, the cooked platforms will be Windows, and the cook culture will be en as default. So yeah, en as default, and the level we want to cook is the LV, sorry, LV exterior. So why is LV exterior? Did I miss this one? Yeah, there is this one, LV exterior. Now here is the main part. So don't tick this one. We don't want to create a release version. We want to create a new release. I will name this one 1.1, and the release version, this is based on like 1.0, like our the previous one. And we want to take this one, generate patch. Go to advanced settings. Now we want to compress the content and uncheck this one, same save packages, and click this one. This will create a Unreal pack file in, and all the updates will go to like in one single file, .pack files. Okay. After that, package will be package and store locally. This will be default, and the deploy will be do not deploy. Now go back. Now, okay. I told you that if I launch the patch one profile, this directory will be overwritten. So better you have to copy your base package project file into another folder like I did. Okay, now Okay, we have saved everything. The environment is night, early morning. Okay, now let's the patch out of it. Just launch profile. Okay, so the packaging has been completed. Click on done. Now, okay, let's close the Unreal project. Okay, so go to the same directory like saved, stage builds, Windows. Yeah, this one. Just run the project. Okay, so as you see, so the game has been updated now. So this is with the new lighting scenario, as we can see. Okay, so let's close the project. So if we browse to our project name, so for this one, Hillside Sample Project, go to Content, go to Packs. You see, there is one pack file and there is another one says Windows underscore 0 underscore P. So this is our original pack file, and the size is 160 megabyte something. Okay, so let me show you something how you can apply the pack file. So let's say this is the base project. So if we go to content packs, you see there is only one pack file and this is the default one. So if we run this game, okay, so this is our game with one lighting scenario, and if we close this one, go to the packs. If I copy the pack file, so this is our patch file, and go to here content packs. If we paste the pack file over here and relaunch the game again, we will see the changes. Oh, okay, yeah, so we can definitely see the changes on our game on the lighting side, and this is how you can create your patch files and apply them in your projects.
Updating large Beam projects is a major pain point. Every minor design change can mean re-uploading gigabytes of data, consuming valuable time. This process is frustrating and inefficient. What if you could update your project in minutes, not hours? Our fully managed upload to patch system is built for this exact problem. We handle the complexity so you don't have to. Make a change, create a lightweight patch file, and upload it. That's it. No more full project re-uploads. Just efficient updates that keep your project agile. Want to see how easy it is? We have a complete guide and a demo project for you to follow. The link is in the description.
Let's now turn to the concept of latency and how we can improve it when it comes to pixel streaming. As you know, latency is always going to be involved when pixel streaming because we are running a game engine in the cloud and streaming the output to the end user. Latency is basically the delay when an action is initiated and when the effect is observed. And the way that we can improve latency is by selecting servers that are closest to our end users. For example, let's say that our end users are located in North America, then it would be best to place a server in North America because the round trip time of the stream will be less, so our latency for the experience is going to be less. Now keep in mind there's always going to be some latency when you're pixel streaming, but one of the best ways that we can guard against or defend against latency is by simply just picking the appropriate region where our server is placed to improve latency. Well, how do we pick the best server? How do we know how to do that? One of the best ways is by simply using AWS because they have regions all over the globe where they have their data centers. And so we can simply just select one of these regions and we can use that to pixel stream our instances from. One important thing to keep in mind, of course, is that not all these regions are going to have the G5 and G6 instances, which are the instances that you would want to use for pixel streaming. So just double check and see which regions have the G5 and G6 instances. I'll provide the links to these releases here so you can kind of see they're sort of listed right here. You know, Europe, Asia Pacific, Canada, North America, and then the same thing for the G5 instances. So you may have to kind of pick, it may not be the exact closest one, but you should be able to find something relatively close in order to reduce latency. And if you also check our YouTube video on how to pixel stream on AWS, we show you exactly how to appropriately select the region so that you place the server in the right location for the best latency.
Showing the mouse cursor in your pixel streaming app is usually a bad idea because no matter how good your internet connection is, even if you are streaming locally, there is always a small amount of latency which can enforce the perception of lag in your users. So it is recommended to hide the Unreal's cursor. To hide the mouse cursor, simply open any blueprint, get a reference to your player controller, and call the node set show mouse cursor. If the value is false, the mouse cursor will be hidden in your game. And if it is true, it will be shown.
Ready to experience seamless pixel streaming? Visit us at eagle3dstreaming.com and follow us on social media for more insights.